Welcome to Dr. Chad's continuing series on calculus videos. Today's lesson is section 3.2 from Rogowski. The first part of it, there's two parts. Well, it's really one section, but we're going to break it in half because there's two ideas. The first idea is, how do you find derivatives for fairly basic functions? The ones you use every day. So, in order to do this, you should be good at algebra. Again, all the algebraic manipulations, you better be good at them. It's helpful if you can graph a function, because remember, from before we learned the derivative is the slope of the tangent line, and when we find a tangent slope, when we find a tangent line, you better be good at that. You should be able to find a limit again. That's less important now, because once we have rules, we won't use the limit definition much. But again, you should know from previous experience what the definition of the derivative is, otherwise this won't make sense. Our goal, actually specifically, the primary goal, is to find these derivatives. X to the n, for actually any n you can think of except maybe 0, because what's x to the 0? It's a number. We don't care so much. F of x plus g of x, or maybe minus 3f of x, or a number times that. E to the x, b to the x for some other b, or actually even for e. And there's another one I want to add in there. It's not necessarily considered its own rule, but nx plus b. What's the derivative of a line? So, our goal is to do those. I'm not going to prove them all. I'm going to pick this one. We'll see how this one works out, and then maybe use your imagination on the rest. Here we go. If f of x is x to the n, and I'm actually going to cheat. I'm going to say I'm only looking at positive integers. Why? Because it's easier. The others work out, but for now, x to the n. We take the derivative definition. F prime of x is the limit as h goes to 0. F of x plus h minus f of x divided by h. That's the one that's easier to work with, and then plugging the f of x we have in, we get here. So what do you do now? If that's x squared, you'd multiply twice. If it's x cubed, you'd multiply 3 times. If it's x to the 7th, you'd multiply 7 times, and you'd say, ugh, that's awful. But the trick here, there is a trick. We're going to multiply, but we're not going to worry so much. I'm going to put the pieces that I actually know first, because that's the same thing. I'm just going to put this in here. Now, if I have, imagine that, x plus h, x plus h, x plus h, all of them. If I just take the very first term of each, I get x to the n. Now, the other terms will have h's in it. How many? Well, imagine h, x, 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 x. That's going to be h times x to the n minus 1. Or how about x, h, x, 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 x. That's going to be h times x to the n minus 1. They're all going to be. And how many are there? There's going to be n of them. So this is going to be a little hard to write. nh x to the n minus 1. And then there's something else right here. Those are terms that have more than one h multiplied on. So what I'm going to call them is h squared times stuff. Because I don't care. I don't care what's in there. And you'll see why in a second. Because expanding this out, this x squared minus x squared, I'm sorry, x to the n, I said x squared. X to the n minus x to the n, 0. So what do we have left? N times h times x to the n minus 1 plus h squared times, I don't know, stuff over h. And again, with these derivatives, what are you going to do? You factor the h's out. I'm going to skip that sort of. Well, no, I won't. I better do it. Here we go. H pulled out. There's just an h on the bottom. What do I have? N. X to the n minus 1 plus h times that magical stuff that we don't actually know what it is, or it will turn out we won't care. Why don't we care? Because these cancel. Now I'm going to let h go to 0. There's no h's here. We're good. But that's h times something. That's something times h. h goes to 0. This is going to be 0 times something, 0 times something, 0. So what are we left with? N x to the n minus 1 plus 0 times stuff. Okay, I'm going to write this on the board and all the other formulas at the same time. So follow me, and we've got some formulas. This works not just for positive integer n, it works for any n except 0, because 0 is kind of complicated. I didn't do it for all of those, but it still works out. The derivative of x to the n is n, x to the n minus 1. If you have two functions, you're adding them, the same. You do the limit definition, you can show that the derivative of one plus the other is the derivative of one plus the derivative of the other, or minus, either way. If you have a number in here, you can pull the number out. So like the derivative of 5x squared is 5 times the derivative of x squared. And e to the x's derivative, work it through, you'll get e to the x. B to the x's derivative, work it through. You don't get b to the x, but you get something close. You get b to the x times the natural log of b. And I added one new one in here. This is a line, right? Y equals mx plus b. If you take the derivative of a line, what is the derivative? It's the slope of the tangent line. So the slope of the tangent line, well, the slope of a tangent line of a line, the line tangent to the line is the line. So what's that slope? It's m. That can come in handy. It's just nice to know. So let's do an example. So I'll keep those rules in the meantime, and let's do this example. It's got a lot of pieces, and not all of them are pretty, but if we work through, we'll figure it out. The first thing we do is to note, over here, the derivative with a plus or a minus in between, you can pull it apart there. So this is going to be the derivative of x to the fourth plus 3x cubed minus pi x squared plus 13 is going to equal the derivative of x to the fourth, that's the first piece, plus the derivative of 3x cubed minus the derivative of pi x squared plus the derivative of 13 by itself. That first one, x to the n rule. The derivative of x to the fourth is 4x cubed. This rule, that 3 sticking out there, can be pulled out. And then this rule here, that becomes 3x squared. So what are we going to get? 3 being pulled out in the first one, times 3x squared. What about this rule? Pi. Pi is a number. It's irrational. Tastes good sometimes. But pi is just a number, so we pull it out. X squared. The derivative of x squared is 2x. So we get pi times 2x. And lastly, this is a number. Well, there's the rule for a number times a function over here. But that's a number times a function. There has to be that kind of function there. So what we're really looking at is this, where m is 0. It's 0x plus 13. So the derivative of that will be 0. So putting it all together, 4x cubed plus 9x squared minus 2 pi x. And that's that derivative. Make sense? Let's try another. Let's try another with some weirder pieces. Here we go. And actually the weirdest piece of this one, it doesn't say find the derivative of it. It says find d over dx. This is Leibniz notation. Leibniz was one of the inventors of calculus. Actually, some say he was the inventor and that Newton sort of borrowed from him. Some say they both did it together and, however it worked out, his notation is different than the prime notation we use, which is Newton's notation. Sometimes this is better, sometimes this is worse. What it says is the derivative of blah with respect to x as being our variable. If you got more than one letter in there, that's nice, because now you know x is our variable. Everything else is constant. But we'll worry about it. We'll treat it, we're just finding the derivative. Now, this first one, this is the derivative of x to the 1.7. So the derivative of that minus the derivative of 1 over x. Now 1 over x doesn't look like what we have. It's a fraction. It's a quotient. And we don't have any rules for quotient yet. But you can write 1 over x as x to a power. This is x to the minus 1. Plus now pi squared, again pi squared, has no x's. It's a constant. So we're taking the derivative of each of these. Did I get my pluses and minuses right? Yep. Okay. The derivative here, 1.7 x to the... Now the rule says you subtract 1 from it. So 1 less than that would be 0.7. Minus, this says we bring that minus 1 down and subtract 1. Subtracting 1 from minus 1 is minus 2. Pi squared is, it's just a number. It fits along like the 13 did before. So its derivative is 0. And then this one, 2 to the x, exponent b to the x. Remember, b to the x's derivative is b to the x, natural log of b. Putting it back into a prettier form. Minus minus here, minus minus makes plus. X to the minus 2, you can leave it like that, or you can just make it 1 over x squared again, and then minus 2 to the x ln 2. These three pieces don't really play well together. They could be combined into a fraction, but I don't think it's going to add anything. So that's how you do it, but let's add one more to find a tangent line. Let's do a more basic function, but something with actually some thought involved. Here it is. Y equals square root of x. And we're going to let x be 4. Here's the graph of square root of x, sort of drawn, and there's the tangent line. Now, to find the derivative of this, we have to convert that to a power of x. So we could rewrite this, y equals x2, and square root of x is the 1/2 power. If you do that, the x to the n rule perfectly applies. So the derivative is going to be n x to the n minus 1. The 1/2 there, the 2 is on the bottom. This is minus 1/2, which makes it on the bottom. We can rewrite this as 2 square root of x. That's the derivative. Now, what do we do with that? That's the slope. Except it's not a slope, it's a formula. Slopes are numbers. So we have to figure out what to do. And the way you figure it out is you find out what point you're at, and you figure it out from there. The point we're at is when x is 4. If x is 4, what is that? That'll tell us its slope. So m is 1 over 2 square root of 4. Now square root of 4 is 2. And then 2 times 2, 4. So this is 1/4. We're almost done. Let's see. That means it's y equals 1/4 x plus something. And how do you figure this out? You find the x value, you find the y value. The x value is 4. The y value, well, we know y is the square root of x. X is 4. Square root of 4 is 2. 2 equals 1/4 of 4. 1/4 of 4 is 1, so what goes there? 1, 2, 1 plus 1. And there's our tangent line. Now let's look back at the graph. Does that look about right? The slope's 1/4. Is that really going up very fast? It could be 1/4. Is it hitting about at 1? That seems believable. That's how you do it. There are some examples. Go at it. You can now do a lot of functions. Next time, we'll look at the rest of the section.